In today's video, we have a car travels 60 meters east and then it travels 20 meters west. We are going to find out the total distance traveled by this car and also the displacement by this car. So let's see how to go about such a problem. And in kinematics, because we always deal with vectors and hence scalars, we need to always define our coordinate system. And in this case, we are going to do the Cartesian coordinate system, which is the XY coordinate system. So we have our vertical axis. So this is the Y axis, and this represents the north. And then down here, the south, which is the negative Y direction. Again, we do have the horizontal axis. Remember, we are dealing with the Cartesian coordinate. So we are going to have the positive X axis, which represents east. As stated in this problem, the car only traveled along the east and west direction. So in the negative X direction, that is where we have the west. So we can place the car at the origin. However, what is the total distance traveled, which is a scalar? So if this car starts from here and then it moved or travels 60 meters east, so 60 meters east means that to the right in the positive X direction. So if we jump this car 6 points, 1, 2, 3, 4, 5, and 6. So it is going to be at this location. So we know it traveled some distance, which is 60 meters, but in the eastern direction, that is along the positive X direction. So that is a displacement, all right? And the distance traveled is just 60 meters. That is the scalar, right? It gives us how far did the car travel from its starting point, which is the origin. And then it traveled 20 meters west. So these jumps are positive jumps, and then it went west. So west means that it is going to start from here and then go 20, which is 1, and then 2, and then it's going to end up here. So in this case, when it comes to distance traveled, it traveled 1, 2, 3, 4, 5, 60 meters east, and then 1, 2, 20 meters west. So the total distance is going to be 60 meters plus 20 meters. So the total distance A is going to be 60 meters. So that is the distance traveled for the first part of the journey towards east plus 20 meters, which is the second part of the journey. So total distance is going to be 60 meters plus 20 meters, and that gives us 80 meters. B, we are also looking at the displacement. So from the origin, this car started from here, and then after traveling 60 meters east in the direction, so that is a vector quantity. So we need to take care of the direction. East is positive X, right? And then it went back 20 meters west, which is in the negative direction. That is in the opposite direction, because from this 60 meters point, it went the negative X direction, and that is the western direction, and that is negative, right? So we have 1, 2. So in this case, if we want to find the displacement, is going to be plus 60 meters. So here the positive only tells us that in the positive X direction, it indicates direction. And according to our coordinate system, east is positive and then west is negative. So going back west is going to be negative. How much distance traveled, which is 20 meters. So this negative sign is nothing but the direction. So with this, we can do 60 meters minus 20 meters, and that is going to be 40 meters. And remember, this is a vector quantity, so it is going to be positive, because after traveling 60 meters to the east and then 20 meters to the west, this car will still be at this point where that is still in the positive X direction or in the eastern direction. The final displacement of this car is going to be 40 meters, and we can see from the origin, or with respect to the origin, is 1, 2, 3, and 4. And this is where the car would be after the total travel. All right. So this is the difference between distance and displacement. And if you find this helpful, Give us a like, share, and also follow for such videos. Until then, I will see you in the next one. Bye-bye.